Right. Good evening, everyone. Online students, can you hear me? Online students, reply. Can you hear me? Everyone tell me. Collections framework is divided into how many hierarchies? Collections are divided into how many hierarchies? Two hierarchies. Collection collection is divided into three types. But I'm asking collections, framework collections. Divided into how many hierarchies? Two. What the two? Collection and map. When we want to store values or objects without identity, we must use collection, hierarchy, classes, set, list, queue. If we want to store objects with mapping, I must use map. So what is a map? What is the use of map? Tell me, what is a map? What is the use of map? Map is a collection. Correct? Map is a collection. What the use of map? First point. A map is a collection. What the use of it? It is used for storing objects with a mapping. Okay, that means what? When we want to or need to store objects in table format as key value. In table key value pair format, we must use map and its implementation classes. Tell me, in a map, tell me, the key must be unique. The value can be duplicate. Four points understood? Next, fifth point. The map cannot store entries in sorting order. Then for storing entries and key value pair is called what? Entry. For storing entries in sorting order, the map has subinterface. What is that? Sorted map. The sorted map has another subinterface, navigable map, for adding more navigation methods. So this is the story about map points. Map is a collection. It is used for storing objects with mapping. When we need to store objects in table key value pair format, we must use map and its implementation classes. In a map, the key is unique and value can be duplicate. The map cannot store entries in sorting order. What is the problem with map? It cannot store objects in sorting order. It stores objects only in hash code order. For storing objects in sorting order, the map has subinterface sorted. The sorted map doesn't have multiple options of methods. For storing objects in another, for adding more navigation methods, the sorted map is having subinterface navigable. Okay. Then tell me, what are the implementation classes of the map? The map has 8 implementation classes. 8 implementation classes. What are they? Number 1, hash map. Okay, let me remove this number. Hash map, linked hash map, enum map, weak hash map, identity hash map, hash table, properties, and last tree map. Totally how many became? Hash map, linked hash map, enum map, weak hash map, identity hash map, hash table, properties, tree map. 3 plus 2, 5 plus 3, 8. The tree map is direct, is an implementation of sorted map. Okay, this is the points about map. Okay, when to use which map, you cannot understand at this stage. I will explain you one by one. When to use hash map, when to use linked hash map. All these classes are meant for storing objects in table key value pair mapping. For with the mapping, if you want to store object with mapping, we always use these objects. That's a fixed. Okay. But the point is, when to use which collection, there is a small differences are there that I'll explain you later. So these are the 8 points on map points. Okay, tell me now. If you create any of these 8 classes objects to perform operations on that object, we need methods now. Okay, what are the methods available in the map? What are the methods available in collection? Same methods available in map. Collection methods are single parameter methods. Map methods are 2 parameter methods. That is only difference. Shall we start? All points understood are these 8 points? Now tell me. Map interface methods. What are the methods available in map interface? First one is what? Add. Public object. Okay. Object. Put. What the method name? Put. Put of object key comma object value. So if you want to store an entry in the collection, I must call what method? Put method. It will take 2 parameters, key comma value. Tell me, key must be unique, duplicate, unique. Value can be duplicate. Suppose I call put of double quotes A comma 97. Is a double quotes A already available or not available? Not available. Then it is stored as a entry. Next, if you are storing calling put method again by passing double quotes A as a key with the value some 1 or 2, then what this put method will do? Will it store this entry or will not store? Will not store. Will not store this entry. Again repeating, this put method will not store the entry. Then what it will do? It will replace the existing value with this new value. That means put method performing only storing operation or replace operation also. 2 operations performing, store and replace. So put method will take the key, compare this key with the existing keys. If same, replace old value with new value. If key is not found, it will store. Whenever the key already available, it replaces the old value with new value and return that old value. Okay, na? Return that old value. Now from Java 5 version onwards, with the generics, the parameter type has changed like this. K, key, V, value. In place of object, we are taking what? K and V. And return type is not object. Return type we are taking what? V. So it's more clarity methods. Okay. V stands for what? Value. So put method store the given entry. If this entry already available, old value replaced with this new value and old value is returned to our program. Tell me now. If you remember, we have add all now. Similarly, come on. Similarly, put all. What it will take? Put all map. So it will add multiple entries at a time and doesn't return any value. Okay, na? Because multiple values returning not possible. So put method return type is object, put all method return type is void. So these two methods are used for adding. After adding, I want to count size. I want to print two strings. The next is search. And tell me, what is the method for searching in the collection? Public. Return type is what? Boolean. Method name is what? Contains. There in the collection only one object available. But here we have two objects, key and value. That's why two methods available. Contains key, K key. Next, contains a value, V value. Okay, clear? So first store, next search. Then after search, next operation is what? Retrieve. For retrieving purpose, public return type is V. You want retrieve value, na? V. Method name is what? Get. Tell me, in a list, get method parameter is index because their object is mapped with a index. Here object is mapped with index a key na? Key. You give the key mapped object will be returned. Next, you have, remember, we have iterator. Here, for retrieving multiple keys, we have a return type set of keys. Return type method is there, keys, key set. What method name? Key set. No. Keys, I guess. Okay. Keys of, don't need to take any parameter. This method returns all keys. No, I don't want keys. I want values. Okay. If you want values, what the method name? Values. All values is a collection, na? Including duplicates is what? Collection. Keys return all keys. All keys group is a unique elements. Unique elements is what? Set. Get method returns only one value, one object. That's the return type is what? V. Keys will return all keys available in the map. That's why return type is what? Set. Values method return all values available in the map. That's why return type is what? Collection. No, sir, I don't want key separately. I don't want value separately. I want both key value as a one object. Then there is a method called entry. Key value pair is called what? Entry. Key value, one object. Key value, another object. Key value, another object. Multiple objects group is what? Set. Entry set. Return type is a set. It implicitly, key value is called entry. Na? There is an object called what? Entry, which will take key comma value. One object is of what type? Entry. All entries are storing inside set. So this is the method for entry set. Repeat once again. How many methods available to retrieve objects from the map? I want retrieve one value. Then method is what? Key. Sorry, get. I want retrieve all keys. I want retrieve all values. I want retrieve key value both together as a one object entry set. In Java 8 version, it is simplified. This entry set method is simplified and provided one new method called void. Void method is for each. Remember in collection we have for each. For each method parameter is consumer. Here the parameter is what? By consumer. By means what? Two objects. By consumer BC. By consumer. Two objects, key value pair is there. That's why by consumer. So for retrieving totally how many methods available? 1, 2, 3, 4, 5. 5 methods available. Okay, na? Next. I want remove object. For remove object, we have straight away one method. Public return type v remove of key. Given key is found, return remove and return value. If a key is not found, returns what? Null. Remove method returns null. Next, I want replace. Public return type is what? Replace v, previous object v, and method name is, I guess, set of what you call key comma v comma new value. If key found, replace existing value with a new value and returns what? Old value. Set method or replace method, we'll see. I didn't remember method name exactly. So tell me, is it not a crude operation? This is what? Create. This is what? Read. Crude operation. Update. And then delete. Tell me, can I use map as a table? Already map is a table only, na? But is it a multi-columns table or two columns table? Two columns. For storing entry or for inserting row, put method. For retrieving the row, get keys, values, entry set for each method. And can I say get method is a select star with where condition? Select a star from table where key equal to given key. Whereas keys method, values method, entry set method for each method with where condition or without where condition? Without where. All keys, all values, all entries. Set method replacing the given key. That means update with where condition. Remove with the where condition. I want to remove all objects. Public void method name is what? Clear. This is with where or without where? Without where. Delete star from student. Deleted all those. So map is nothing but what? Map is nothing but database table. It is used for performing create, read, update, delete operations. Is it clear? Shall I perform operations now? So let me show you all points in the notes. Not point one, method one. Put method, storing object. If already available, replace. Set method, only replace. Understand? This is your map class. All classes available here. Map interface and its points. Map is a root interface of map hierarchy. It is a collection with mappings. It is a part of collections framework available from one point. If you want to store objects with mappings, if you want to store an object in key value pair table format, we must use map. Map interface doesn't maintain insertion order and doesn't have index. Map interface has one subinterface sorted map and it has a subinterface navigable map for storing entries in sorting order. Sorted map interface is for storing entries on keys based sorting order. It is also available from Java 1.2. Navigable map is given in Java 6 version for adding more navigation method to sorted map. Map interface has 7 implementation classes. 5 are collections framework collection and 2 are legacy classes. Hash map, linked hash map, enum map, weak hash map, identity hash map, hash table properties. Sorted map and navigable map has only one implementation class, tree map. Totally how many? 8. Map, sorted map, navigable map, abstract map, all the hierarchy diagram. When to choose which? We must choose a hash table to store unique entries in a multi-threaded application. We must choose a hash map to store unique entries in single-thread application. Linked hash map for storing unique entries in insertion order. Weak hash map with a weak reference. Identity hash map with a reference-wise hash code. Enum map for storing one enum named constants. We must use tree map for storing entries in sorting order. We must choose properties for storing entries in the file permanently. Map interface methods. How many methods available? 35 methods. Okay, 35 methods available. No need to learn all 35 methods. Okay, for adding, put if option, put all. Put method will store or replace. Put if absent method will only store. If not available, it will store. If already available, it will do nothing. No, sir, I want to store. If already available, replace. Call put method. I want only store if not available. Call what? Put if absent. Next, put all method for copying one entries from one map to another map. Searching key or value. Contains key, contains value. Retrieving value. Get or default. If you call get method, if this key is not available, it returns a null. Hey, I don't want null. I want a default value. Then call what method? Get or default. Okay. Next, key set, values, entry set for each. I want remove. Remove of key. Remove of key comma value. What the difference between these two methods? Why backend some? Even the projector, huh? Handset problem. Look at here. Remove method will remove the key. For example, remove and killing na. I send information. I given a supari to one rowdy shooter, told him in 404 room number 404, chair 1 student kill. Whoever sit here, he will come and kill. That is called remove of key. What information I given? Chair 1. Inside chair 1, whom I want to kill? Hare Krishna. But here, Hare Krishna not there. Some other faculty there. He will come and kill him, na? Right or wrong? Wrong. Right or wrong? Clarity, more clarity. If you find key, room number 404 found, chair 1 found. Don't kill immediately. Check the value, Hare Krishna. If key and value both are matched, then remove. Otherwise, don't remove. Just based on key you want remove, use first method. You want to use both key and value mapping and remove, then use what? Second method. Which value? New value or old value? Old value. Already available value. All entries I want remove, make the map empty. Then call what? Clear. Understand 3 methods. Put if option. If not available, then only store. Otherwise, don't store. Get or default. If available, return the object. If not available, return the string default value. Don't return null. Remove key comma value. Just with key mapping, don't remove. Value also should be matched. Then only remove. Both match and remove. That's a extra layer of protection. Replace. For replacing, we have already put method. I don't want put method. I want replace method, exclusive replace method. Observe. Replace key old value with a new value. Here also problem. If key matched, immediately old value replace. No. For example, I am management sent a management sent. Okay, go to room number 404, seat number 1, replace the student. Which student available? Hare Krishna. But which student they want replace? Balkrishna. Okay, na? That means they have to give extra information. What is that? Key and matched value. Both are matched. Then replace this old value with new value. Just based on the key matching, you replace. Then use what? First method. I want a key value. Both want to consider to replace. Then use what? Second method. Then replace all. All keys, all values I want to replace with some function, some logic. Then you call what? Replace all by function. Okay. Then counting entries is empty size. Retrieving hash code equal. Then I want to create map object with Java 9 off method. I want to create a collection of copy elements from one map to another map by using copy of. So the major methods are what? Up to remove. Up to replace. Tell me, do you have any method for inserting? In the table, in the middle, can you insert? No. Insert means adding only. In database table, inserting is nothing but adding. That adding is nothing but which method? Put. So totally how many operation? Adding, searching, retrieving, removing, replacing, and counting. These are the 6 major operations. Adding, searching, retrieving, removing, replacing, counting. For that, totally 17 methods available. So all points are clearly documented. Hope you will practice. I practiced. I remember. You also practiced. You will also do. Online students. Then I want to move to the first collection. Ready? What is the first collection? Map. Working with hash map. Point number 1. What is hash map? The hash map is a collections framework, collection or map. Generally, don't call it collection, we call it as map. It's a collections framework map. It is available from 1.2 version. It is an implementation of map interface. What is the use of it? For storing unique entries in hash code order in a single thread model application or in method local operation without thread safety. We must choose. Okay, let me change little bit. It is used for storing objects with a mapping in key comma value pair in hash code order in a single thread model application or in method local operation without thread safety. We must choose hash map. Is it a synchronized map? No. Is it ordered map? No. No. Hash code order is changing the order. Na? Next, its implement data structure is hash table. Okay, hash table. Data structure name is hash table. The table key value pair is technically called what? Hash table. Next, its a default capacity is 16. That means this hash table is created with a default capacity how many locations? 16 locations. ప్రొజెక్టర్ ఆగిపోతా అని అవుతా ఉంది అది వెళ్ళిపోయింది ఏదైనా కనెక్షన్ ప్రాబ్లమా tell me what is the incremental capacity? Default capacity 16, incremental capacity double, incremental capacity double or plus 1. Load factor, what is the meaning of load factor? When its capacity is increased, not 100%, 75%, 0.75. And when 12 objects are stored, 16, 75% means what? 12. When 12 entries are stored, its capacity become double. I'll show you that practical. I repeat again. What is hash map? Collections framework map available from 1.2 version. It is an implementation of map interface. Next, when to choose hash map? For storing objects with key mapping. For storing objects with mapping in key value pair format in single thread model application without thread safety. Is it a synchronized map? No. Is it ordered map? No, because it doesn't guarantee retrieving order, say constant retrieving order. Next, what is the implement data structure? Hash table. What is the default capacity? 16. What is the incremental capacity? Double. What is the load factor? 0.75. Tell me, what type of objects are stored? Here you are storing one object or two objects? Two objects. Key and value. What type of keys are allowed? Unique. Homogeneous or heterogeneous or both? Both. Keys, allowed keys, homogeneous, heterogeneous and unique. Allowed values, homogeneous, heterogeneous, unique and duplicate. Next, is the null allowed? As the key allowed, how many? One null. As value allowed? Yes. How many? Multiple, because duplicates are allowed. Let us see these points. Let me write a program. I written a program already. I don't want to waste your time by again and again typing. Okay. Let me write. I created a hash map object. System.out.println hm.size. What the size of this map? No elements. What are the elements available in hash map? No elements. Observe what is printed. Previously, for collection hierarchy classes, square bracket is printed. For map, what is printed? Flower bracket. If collection printed with flower brackets, that is map. If square bracket is printed, that is collection. Now I want to store objects. System.out.println hm dot. What is the method for storing? Put of double quotes a storing one. Tell me, put method returns null if the key is not available. If available, returns the existing value. Now I am printing hm. What is written? Null. Why? Because the key is not available. It's empty collection, empty map, key is not available. So it stored the entry. Now I am giving a again with value 2. What happened? What happened? Key is already available now. Will it store this key again? No. That means size increased or not increased? Not increased. Previous value 1 is replaced with 2 and returns that 1. Returns 1, a equal to 2 and size is what? 1. Understand online students? Then hm dot put of heterogeneous objects allowed? Yes. Now 3. And tell me, now what returns? Null. Size 2. Where it is storing? Right side. Is it insertion order or hash code order? Hash code order. Now, I am storing 97 4. Tell me, do you have the key 97? No. Then is the key 97 with value 4 stored? Yes. Returns what? Null. But where this 97 is stored? After B na, after A na? After A. Because it is hash code order. Understand a hash code order means what? Same object, the objects with the same hash code stored as a group. Different hash code objects are stored as another group. Tell me now. Now I am storing put of 98 comma 5. Stored or not stored? Stored. Where? After A, after 97, after B, after B. Why? Because hash code of B and 98 same. Next, I am writing something like this. Try to observe now. Null I am writing. Can I take key as a null? Yes. 6. Is there any key with the value null? No. Then it is stored. Where null is stored? In a 0 location. The hash code of the null is what? 0. That's why it is going first location. So tell me, is it insertion order or hash code order? Hash code order. Next, now I am trying to store null again by giving 7. So tell me, null again stored or not stored? Not stored. So what is written? 6 written, and what value stored again? Null equal to 7. 6 replaced with a 7. Now I am writing here my class object new example of 5 comma 6 by giving value 7 only. Is it accepted or not accepted? Accepted. Duplicate values are allowed? Allowed. What returns? Null. Because new example object is not available as a key. Everyone try to think an answer. If I store new example with the same value 5, 6 with the value 8, tell me now. New example, second time, stored or not stored? Stored or not stored? Everyone should answer. Stored or not stored? Stored. Daily same lesson I am teaching. తెలుగులో రోజు అదే పాఠం చెప్తున్నా. Put method must stop storing duplicate keys. For that, presently adding key compared with the available keys, how many ways? 2 ways. Either with reference or with data. Is it the hash map put method decision to compare key with reference or data, or is that the decision of the example class developer? Example class developer. How example class developer will tell to the hash map? Compare my objects using reference, compare my objects by using data. Put method internally calls which method? 2 methods. Hash code method and equals method. If hash code equals methods are not overridden, it compare the example class object with the objects available in the collection by using reference. If overridden, compare by using data. Tell me now. Tell me now. Integer class, string class, hash code and equals methods are overridden? Yes. That's why the duplicate object is stopped based on data. In example class, did you override hash code and equals method? No. In example class, you didn't override hash code and equals method. Dekho. Then what happened? Example object is compared with this second example object compared with this first example object by using reference. Reference is same on different. Reference wise, these objects are unique objects or duplicate object? Duplicate. Reference same or not same? Not same. Then reference wise, this object is unique or duplicate? Unique. Unique means stored or not stored? Stored. 2 times stored. Understand? Tell me now. Again, I'm asking same question. Repeating. Repeating, new sample with 1 second, please. Tell me now. Here, sample class object is stored with reference say 9 and this reference is 10. And tell me now, second time, new sample object is stored or not stored? Come on. Stored or not stored? Not stored. Why? Now, the second object is considered reference wise comparison or data wise comparison. Why? In a sample class, we have overridden hash code and equals. Understood? And tell me, whenever you are working with what hash table data structure based collection or map, you must verify whether hash code and equals method both are overridden or not. If not, compare by using reference. If yes, compare by using data. Came this point here, right? As long as you didn't accept this statement, you will not understand collections. You will not understand data structures. Lifelong, it's confusion only. మీరు చూడాల్సింది ఒకటే ఏంటది నేను యాడ్ చేస్తున్న క్లాస్లో హ్యాష్ కోడ్ ఈక్వల్స్ మెథడ్స్ ఓవర్ రైడ్ చేశానా చేయలేదా చేస్తే డేటాని కంపేర్ చేయాలి చేయకపోతే రిఫరెన్స్ని కంపేర్ చేయాలి हमारे क्लास में हैश कोड इक्वल्स मेथड ओवरराइड किया नहीं किया देखना पड़ता है ओवरराइड है तो डेटा कंपेयर करो ओवरराइड नहीं है तो रेफरेंस कंपेयर करो ये स्टेटमेंट तुम्हारा मन में स्टोर करना पड़ता है बाद में यूज करना पड़ता है नहीं तो ऑलवेज हिंदी क्या बोलता हमेशा इंटरव्यूज में फेल होता ओके ना जॉब नहीं आता अमीर पेट का सीनियर स्टूडेंट होता अंडरस्टैंड माय पॉइंट दिस इज सिंपल पॉइंट इतना छोटा पॉइंट याद रखना पड़ता है इसमें समझ में नहीं आ रहा है सर क्यों समझ में आ रहा है याद रखो ये एल्गोरिथम है कृपया ध्यान दीजिए ओके यात्रीगण वो ट्रेन इसका प्लेटफॉर्म में आ रहा है देखना पड़ता है ओके ना सेम थिंग whenever you are trying to add your class object to hash map nothing but hash table data structure collection immediately open that class check whether hash code equals methods are overridden if not overridden compare what reference if overridden compare what data is it clear paka really then tell me is it added or not added new string of double quotes a 11 bolo is it stored or not stored why not stored this double quotes a string already available no but this string object reference This newly storing string object reference are both same or not same? Not same. Then they are unique or duplicate? Unique. Based on the reference, they are unique objects. But that is the reference wise unique or data wise unique or decided by put method or equals method or equals method. Inside string class, hash code and equals methods are overridden or not? If hash code and equals methods are overridden, is it compared by using reference or compared by using data? Na? What is the data of the string object? A. What the data of already available string object? A. Now, this is second string object considered as a duplicate or unique? Duplicate. Duplicate means old value replaced with A replaced with what? 11. Okay, na? Observe here. For our sample class, hash code method is called hash code and equals method is called for comparing. Okay. For the time being, I am commenting that messages. When I'm explaining internal algorithm, I'll explain. As of now, I want to register one point in your mind. What is that? Whenever I am storing my objects in hash map, क्या देखना पड़ता है? Hash code equals methods overridden or not देखना पड़ता है. खत्म. That's it. Everyone tell me. Now I'm writing new integer of 97. New integer of 97, 12. And tell me 97 with the 97 integer object already available. But is it same reference object or new reference object? Now integer object is compared with the existing integer object with reference or with the data? Na? With the data. Because hash code and equals methods are overridden in integer class. Control F11. Look at there. 97, 4 is replaced with 12. Totally, how many objects are available? 8. Now, I'm storing 9th object, single quote P equal to 13. Is it stored or not? Yes. Where? Somewhere based on its hash code. Okay. Next, I'm storing true, 14. Stored or not? Yes. Where? Based on its hash code. Somewhere it will go and sit. कहाँ है तुम? अरे ट्रू वाला कहाँ है तुम? हाँ इधर है. Okay. Next, now I am storing 6.7 with 15. Is it stored? Yes. Somewhere in hash code number it is storing. Next, false. 17, 16, 16. Control F11. How many objects are available? 12 objects. Size reached to threshold. Size reached to load factor. What is the load factor? 75. 75 means what? 12. Okay. 12 entries I stored. Now I am trying to store 13th entry. When I store 13th entry, let's say single quote X single quote 17. Tell me, the capacity is increased to double and the positions of all these objects will be changed. Changed? Up to here 12. Okay. When I store X equal to 17, 13th object, observe all the objects positions are changed. Null equal to 7 position not changed because always it is 0. Then A equal to 11, P equal to 13 place, A equal to 11, 97, 12. Next example object coming, B equal to 3, 98, 5. False equal to 16 place, sample. 6.7, 15 place, example. SA of this place, true. And P equal to 13, false equal to 16, 66.7 equal to 15, X equal to 17. And tell me now, hash table is, hash map is ordered collection or unordered collection? Look at there, their entire object's position is got changed. So it cannot guarantee the retrieving order. That's why it is called what? Unordered collection. Objects are changed their position. This concept is called rehashing. What do you call? rehashing. Whenever the capacity is increased, automatically object's position is changed. That object's position changed concept is called what? Rehashing. Okay, finally, 3 points I want registered in your mind. Point number 1, I should use a hash map for storing entries in key object hash code order. Which object? Key object or value object? Key object. Key objects hash code order. Second point, when we pass an entry to the put method internally calls hash code double equal to operator equals method on the adding object, key. If a hash code double equal to operator equals method not overridden in the adding object class, this adding object compared with already available object by using reference. If a hash code method is already overridden, hash code and equals methods are overridden, the adding object key compared with the existing keys by using data. Understand? When we store 12 objects, when you're trying to store 13th entry, then object's position is changed because hash map capacity is increased and the position got changed. These are the points you should understand. Now that is the 10th point, 11th point. Now what is that? Storing order is keys hash code order written by object class hash code method, either from adding key object class or from object class. If you would override, adding key objects class written. If not overridden, written from object class based on reference. The retrieving order is keys only sequential, values both random and sequential. In adding, searching, retrieving, adding, searching, retrieving, and removing. Replacing also. Removing and replacing operations internally. What is called hash code double equal to operator and equals methods are called, and they are executed from adding keys object class or from java.lang.object class if they have not overridden. If hash code and equals methods are overridden in adding key objects class, the adding key is compared with the keys available map by using data. Data is nothing but state. If not overridden, it is compared with reference. Then it is compared with a reference. Then what happened problem? Then the data wise duplicate keys are stored in map, and further the added entries are not found with new referenced object. Okay, so always we must override hash code and equals methods. Then next, available constructor, for constructor, no parameter collection. Map parameter, initial capacity comma load factor. And this is the probe we have done. Hash map main functionality understood? I didn't explain memory diagram. Okay. Now let's go point by point. Hash map points. Hash map point just now we have shown you. Hash map internals equals and hash code.txt. Online students, Any doubts up to now? Did you get some idea on hash map working functionality? Slowly read my question. Explanation on hash set, hash map, hash table internals, or explanation on set.add, map.put method algorithm in hash set, linked hash set, hash map, linked hash map, hash table for storing unique objects or unique entries. How can a hash map stop storing duplicates? Answer, by using hash code, double equal to operator and equals method. If this point not comes to your brain, lifelong you will confuse again, I am saying. Now slowly read by point. It follows below data structure and algorithm. First algorithm. The classes those contain the word hash in their name internally uses hash code, double equal to operator and equals methods for stop storing duplicate objects and also used for searching, retrieving and removing correct element correct value from set and map based collections in add, put, contains, get and remove methods. Did you get this point to your brain? The classes that contain the word hash, they internally uses hash code, double equal to operator and equals method. Then tell me, among them, first what is called, next what is called? Inside add, put, contains, get and remove methods. First, hash code method is called. Next, double equal to operator is used. Finally, equals method is called. There is a order, zigzag order now. First always hash code. Second, double equal to. Then next, equals method. Okay, na? Do you remember your childhood school? School. You have only one room in your school or multiple rooms? Multiple rooms there. One class, one room, na? LKG, UKG. That is separate building. You know, nursery, kindergarten, that is separated. Then first class onwards, another building. First class, second class, third class, fourth class, fifth class. Principal room. The next, sixth class, high school, na? Sixth class, seventh class, eighth class, ninth class, 10th class. Oh, no, sir, in my school we have sections also. My school doesn't have sections. Okay, now I am talking about my school. Okay, my school is wonderful school. Okay, we have 10 rooms, including principal room. Socho, carefully socho. Tell me, when a child is come to the school, is he going any one of the room available in the school? No. The school teacher or a principal asking this child, hey, which class you are? Then he saying, I am first class student. Then this teacher telling, go into this room. Yes or no? That room number, the room identity is what? Hash code. Understand? And tell me again. Hash map is your school. All 10 rooms, that big place is what? Hash map. This hash map internally contains multiple rooms. How many rooms? Based on the unique hash code. Class 1, one group, one room. Hash code number 2, second room. Hash code number 3, third room. Hash code number 4, fourth room. This room is technically called bucket. What do you call? Bucket. B-U-C-K-E-T, bucket. Online students, listening? Visualizing? Everyone visualize. There is a school, big premises, 4 walls. And this 4 walls divided into 10 rooms. Each room is identified by one number. That unique number is technically called what? Bucket. Okay, hash code, that's called bucket. This bucket is created based on the unique hash code number. Are you catching my point? Repeating again, this entire school is called hash map or hash table. Hash table, assume a hash table, hash table. This hash table, does it storing given entry directly? No. It is maintaining the entries storing based on what? Groups. The group is technically called what? Bucket. First group, first bucket, second bucket, third bucket. When the new bucket is created, when a new hash code object is came, new bucket is created. Presently, I started a new school above. I don't want to invest the huge amount. Okay, capital I don't want. Only I'm starting LKG. Then how many rooms are required? One room. Okay, next year, this LKG students become UKG, na? You wanted to lose these students? No, 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 no. I want to make them UKG and again I want to give admission to LKG. Then tell me, UKG students, LKG student, both we will store in a single room or two separate rooms? That means I have to create one more. Come on. One more bucket. UKG is another hash code. For this UKG hash code, another bucket. Okay, now? Then third year coming. Then third year, tell me, this UKG students become what? First class. You want to send those UKG 30 students to the another school? No, no, no. Then what you do? I will find one more room. I will construct one more room. Why you are constructing one more room? Because another new hash code came. What is the hash code? First standard. Then another room, another bucket created. All these UKG students are throwing into first class. LKG students are throwing into UKG. New admissions are throwing into LKG. Understand? Got clarity? Visualization coming? Now tell me, what is the purpose of hash code? Is hash code meant for comparing one object to another object or for grouping the objects? Come on. Are you comparing one object to another object using hash code? No. Hash code method is not meant for comparing. What is the purpose of hash map? Stop storing. What is the purpose of hash map? Stop storing duplicate object. How can we stop storing duplicate object? The new object compare with the existing object. For comparing, we have already two people. What the two people? Double equal to operator and equals method. Okay, na? Then what is the need of hash code method? Hash code method not meant for comparing. Hash code method is meant for finding the group of this object. When a new student coming into the class, into the school, then the principal standing there and asking, which class student you are? Which class? The class number is nothing but group. The class number is nothing but room. The class number is nothing but bucket. He's saying, my hash code number is first class. I have to go to room number 3. Are you following? Now the another student is coming. He also told my hash code number is first class. Then he said directly go into that room? No. In his mind, the first student face is already available now. The second student also coming with the same face. Then tell me, that means he compared second student face with the first student face. Both faces are looking same. Then immediately principal hold his hand and going into that room, comparing the student with that student or not. If they found both are same, catching the student asking, tum kaun hai? Yes or no? You are a duplicate, not allowed go into this classroom. You didn't pay any extra money. Admission not taken. Only one student admission. 2 students are going. In a RTO, they private travel. Sometimes you heard this. Private travels are running 2 buses with the same registration number. 2 buses they're running same registration number. When RTO did an inspection, then immediately one bus is already going. One more bus also coming with the same number, catching, and fine is getting earned. That means the registration number is what? Comparison. Okay, how this registration number comparison done? By using double equal to operator and equals method. But where they are running in the same road, on the same road, same state is what? Hash code. The same group, one state is one hash code, another state is another hash code. Are you following my point? TS09, TS is what? Hash code. AP is what? Hash code. Tell me, TS, AP, that last 4 digits can be same or not? Yes, sir. Okay, but first code TS, TG, AP cannot be same. So finally tell me, what is the use of hash code method? What is the use of double equal to operator equals method? Hash code method is meant for finding the bucket of this object. If a bucket already available, then compare the objects available in the bucket with this bucket by using double equal to and equals method. If a bucket not available, that means it's a first object. Then the new bucket created, this object directly added. Everyone understand? Then tell me, I am sending double quotes A. First put method internally calling what? Hash code method. What the hash code number coming? 97. With this 97, bucket available or not available? Not available. Then the new bucket is created, object is stored. Understand? Visualizing a bucket and a circle. Next. Now I call put method by giving double quotes B. Tell me, is this newly adding object compared with the double quotes or not compared? Not compared. So when the second object compared with the first object, if both objects hash code is same, that means when hash collision is occurred, what? When hash collision is occurred, collision and same. When two trains are coming on the same track, collision is occurred. First object hash code, second object hash code number, same as a first object hash code number, then hash collision is occurred. When hash collision is occurred, we must compare this second object is the same as the first object. If same, don't store. If not same, store. Where? In different bucket or same bucket? Same bucket. Are you ready? Tell me now. Put off double quotes B. Double quotes B hash code number is what? 98. 98 bucket available or not available? Not available. Then it immediately create what? New bucket. Double quotes B directly stored. Comparison happened or not happened? Not happened. Now tell me, very important part, third point. Put off 97. Tell me. Now put method again apply the same algorithm. What is that? Call hash code method. 97 dot hash code. What is coming? 97. And tell me, with the 97, bucket available or not available? Come on. Bucket available or not available? Available na, double quotes say hash code number 97. 97 bucket is created na. Tell me, now hash code method is used for what purpose? Finding this object bucket. If not available, create. If available, allow to compare. Now tell me, inside hash table, how many objects available? 2 objects, A and B. Now the 97 compared with both objects are only one object. One object. Which object? 97 bucket A. 97 double equal to double quotes A? No. Their references are same or not same? Not same. References wise, they are different object. Maybe data wise the same object na. Then it's called 97 dot equals of double quotes A. Equals method returns true na false? False. Double equal to operator return false. Equals method also return false. Then 97 considered as duplicate or unique? Unique and stored in the same bucket. Visualizing must visualize. No, sir, you draw. I will not draw. I will not draw. Okay. Now, next coming 2 to 3 days, batch is completing. Okay. Your team leader will trying to explain something. He will not draw diagrams on the board. He will orally telling, the project that right side corner, there is a button, move that button to left side. Which button, which left side? What are you talking? Visualize. Sun Microsystem also given me theory. I draw the diagrams by reading the theory. You also draw. Hash map internally uses hash table data structure. Hash table ante one table with 2 columns dabba. Object circle, has table box with two columns vertical line. Okay, na? Then first column is what? Key. Second column is what? Value. Has table data structure internally stores entries by using bucket. You have bucket na? Snanam doing bucket. Washroom bucket. Okay. That bucket only. Drum diagram. Okay. Okay. Drum circle inside bucket diagram. Tell me. Has table by default has a bucket or no bucket? No bucket. Initial it is empty. When bucket is created? When object you are adding. Which object? Same hash code object and new hash code object. New hash code object. When you try to store a new hash code object, new bucket is created. When you try to store existing hash code object, the new bucket created, it is adding to the existing bucket. Added to the existing bucket. Directly added, compared and added. Compared and added. Why? Duplicates allowed or not allowed? Not allowed. When it is comparing, will it compare every object available in the table or only in the same hash code bucket? 3 points. 3 points. First point, table. Second point, bucket. Third point, storing in the bucket. Fourth point, before storing, compare and store. If found unique, stored. If found duplicate, not stored. How to compare? How to find the bucket? Hash code method. How to compare? Double equal to operator and equals method. Double equal to operator compare objects by using reference. Equals method compare objects by using. Bola. Either reference or data based on overriding. Never forget it. If equals method is overridden, data compared. If not overridden, reference compared. Tell me again. Inside add method, put method, contains method, get and remove method. First hash code method is called. Next double equal to operator is used. Finally equals method is called. Okay na? రేపు ఉంటుందరా మీకు భజన టుడే జస్ట్ ఇంట్రడక్షన్ టుమారో ఐ విల్ టార్చర్ యూ లైక్ ఎనీథింగ్ రెడీ ఫర్ టార్చర్ టుమారో write on this algorithm. Hash map internals algorithm. Data structure I am not explaining. First I am telling algorithm. How algorithm is working. Algorithm ante coding part. Tomorrow hash map internals example will be completed. Today introduction. Algorithm only I explained. Internals I didn't explain. Today just I explained algorithm. This is algorithm. Write on first. Hash map internals algorithm or hash map algorithm. Okay, 1 minute. Better write this. Write these 2 points or from here to here. Check, you have to write 15 minutes time there. In this 15 minutes, these points should be completed. Completed? Write this line. First element, second element. Done? If first object, second object, both same hash code, then second object compare first object by using reference. If true, not added. If false means different object, then calls what? Equals method. Equals method returns true, not added. Returns false, added. Where different bucket or same bucket? Same bucket. That means when double equal to operator, equals method, both returns false, then only added. Any one of them returns true, not added. This is a simple algorithm. Okay, please by heart this algorithm and these 3 points. Tomorrow I'll explain you with internal DAG. Okay, clearer? Thank you. That's all for today class. See you tomorrow. Okay, thank you. See you all tomorrow at same time, 6 o'clock.